Okay, so whenever we have a higher order differential equation, when it is of degree basically, when it's of degree 3, when it's of degree 4, when it's of degree 5, one of the ways we can basically solve it is by synthetic division. So I'm showing you in this problem how to work with synthetic division. So this is a differential equation of degree 3. So it's a cubic differential equation. So your auxiliary equation is 16m cube plus 8m square plus m plus 9 equal to 0. So using synthetic division, this is what we do. Now there are different ways of thinking about it. What we first do is, I will tell you, you will list out here, if you notice, you list out over here the coefficients of m cube, coefficient of m square, coefficient of m, coefficient of, or rather the constant here. Okay, I've just written them over there, m cube, m square, m, constant. So we list that out. Once we list that out, we draw a horizontal line and a vertical line in this fashion. The first number, 16, we bring it down as it is. Okay, that's the first thing you do. Now what you're going to do is you're going to be putting down a number here which could be a possible root. Now the question is, when do you know that whatever number you have chosen and put here is going to be correct? Whatever number you choose here will have to give you a 0 over here. The moment you get a 0 over here, you know that you have chosen the right number. Now the question is again, what are the possible numbers I will choose? To get a 0 here, I basically need to get, now if this last number is 9, I would have to get a minus 9, because when I add the 2, I should get a 0. So the only way is to get a minus 9. So obviously, the number that I put in here has to be a factor of 9. The number that I put in here should be a factor of 9. And the factor of 9 is plus or minus 1, plus or minus 3, plus or minus 9. So we start with either plus or minus 1. So I've started with minus 1. Alright. So 16 has come down as it is. What I do is minus 1 I will multiply by 16. I'll get minus 16. I note that here. So that is minus 16. 8 and minus 16 have to be added. 8 and minus 16 gives me what? Minus 8. Then I multiply minus 1 with minus 8. What will I get? Plus 8. Place it here. Then I add 1 plus 8 is 9. Then what do I do again? Minus 1 I multiply by 9. That will be minus 9. Now I add 9 plus minus 9 gives me 0. I am done. The choice of minus 1 is perfect. So one of the roots of this equation is going to be minus 1. Since it's a cubic equation, we are going to get 3 roots. One root is minus 1, which we have already found. So minus 1 is one root. Now we have to go ahead and find the next 2 roots. How do I find the next 2 roots? Now if you notice, we've still got numbers here. These numbers will correspond to the coefficients of the next higher order auxiliary equation. Your initial auxiliary equation was of degree 3. Now your next auxiliary equation will be of degree 2. So this 16 will be the coefficient of m square, minus 8 will be the coefficient of m, and 9 will be the constant. So you get a new equation. 16m square minus 8m plus 9 equal to 0. Solve this. This is your quadratic equation. When you solve and get the quadratic equation, you will see that the roots are 8 plus or minus I root of 5 by root of 512 upon 32. So therefore, what kind of roots have you got? One root is a real number, which is minus 1. Another root is 8 plus I root of 512 upon 32. And the other root is 8 minus I root of 512 upon 32. So you have 3 roots. So therefore this will correspond to, if you want to get the complementary function, this will correspond to, because this is a real root and a distinct root, it will correspond to case 1. And these two are imaginary roots which will correspond to case 3. So alpha, in case 3, your alpha will be 8 upon 32 and your beta will be root of 512 upon 32.